Bismillah ar-Rahman ar-Rahim. This is the second lecture in this course. In last lecture we have discussed the following. We talked about different types of systems, and we focused on information systems. We said that information systems is also the applications around us are almost information systems. Give examples. We said ODAS, our academic system here in the university, banking system, ticket reservation system, supermarket, traffic department. All of these are information systems, and we then discussed that information systems, the core of our information system is data, or depends mainly on data. Where to store data? Data are stored in databases. So data are stored in databases. Here are some examples of information systems. Then we discuss what's the difference between data and information. We say data are the raw information. They are the inputs to produce information. And we have seen that when these are different types of data, numbers, text, date and time, images, sound, videos, and so on. All of these are samples or types of data. Data processed will produce information. So information is an outcome of processing data. We also discuss why do we need information or information systems in order to take decisions. So the decisions have to be accurate, have to be on time. If they are not accurate, then if the information are not accurate, then my decision will not be accurate. Garbage in, garbage out. So I need accurate information. Also, I need the information to come on time, on the proper time. If it came late, then I'll not be able to take the decision at the proper time. So they are useless. If they came late, they are useless. That's why we use information systems. Information systems to bring information in order to make decisions. So to produce information, we need data, and we need the data to be stored in a way that ease or simplify the retrieval. Retrieval means bringing them, obtaining the information. Retrieving information means bringing the information from the database. And we gave examples to make data and information, the difference between data and information clear. We said data are those given inputs. For example, if you fill in a form like student information form, so everything you write in this form is a piece of data. Student ID, student name, date of birth, address, and so on. These are data. I cannot infer. I cannot compute. These have to be given. The marks in the exams or in the finals of the courses also have to be given. Nobody can guess by looking at the face of a student, say this have obtained 70 or 75 or 80 or whatever. But there must be an input. The instructor will provide an input to the system for these marks. But when I'm asking about the GPA, then this GPA comes from the marks. So we bring from the database the marks, do some processing, gets into an equation, we will get the GPA. So GPA is a piece of information. Another piece of information is how many students got an A. Nobody have entered to the system 5 students got an A, but we submit only the marks. But we need, in order to know the how many got an A, we need to process the marks. We need to process the records. So we go and go and count how many obtained a mark that's higher than LAB90 or whatever. So there is some processing. So this means it is a piece of information. So this is the difference between data information, and we need to make it clear, this definition. I mean the difference between the two terminology. Let us, what is the motivation? Why do we need database? How to compare database to other approaches of storing data and manipulating data? Early enough, 20, 30 years ago, the approach was different. Before inventing the concept of database, what they were doing. In order to understand this, let us see an example. What I'm trying to do now is to motivate the use of database. This is not the only way of storing data. We have many ways of storing data. But the best of them nowadays, until now, is the database. What other approaches? There is an approach called file system, and this was the most commonly used by programmers before inventing the concept of a database. قبل ما نخترع database كان في حاجة اسمها file system. So let's try to compare both together in order to get some advantages, to get more understanding on what database and what database, the concept of a database can provide us. So let's forget this for now. Let's consider this example or this picture. Let me assume a hypothetical organization, a hypothetical company, شركة افتراضية. This company is called Dream Home. This Dream Home is working in the real estate, samsara. They are managing or operating or the houses. So a client who owns an apartment, for example, goes to them, to Dream Home, and say, here is my apartment. I want you to find a renter. I want you to operate or manage, collect the rents, do the maintenance, everything. Of course, in behalf of or for a certain charge. So I'm going to pay you certain charge, certain amount of money, and you manage. I don't have any time to manage the property. Let's assume here that we have two departments in this Dream Home organization. One is the sales department and one is the contracts department. The two departments want to use the computer in order to manage their operation. So they hired programmers, but it doesn't. It's not necessarily that the two programmers for the two departments are the same. Maybe they are two different companies, two different programmers. The sales department needs to keep track means stores data about what? About the properties for rent. Sales department is the department that goes and try to sell, to find some customers, some clients to rent the apartments. أكيد لو في حاجة مش متابعها اسألني. So they need to keep track what are these apartments that we are going to operate or manage. So we ask them what type of data, what do you want to store about these properties for rent? So they say every property has a property number, and then we need to keep track of the address, street, city, and postcode, and also we need to keep track of the type. By the type here, we mean it's a house, it's a apartment, it's a studio, it's the type of the apartment. It's a palace, whatever it is. And the number of rooms, the rent per month, and who is the owner. Every owner has an owner number, so we store the owner number. We also, here is the owner. We need to keep track on some data about the owners, private owners. So we have, every owner has a number, first name, last name, address, and a telephone number. Also, we need to keep track of the clients. Who are the clients? Who are those people looking for apartments to rent? Client number, first name, last name, address, telephone number, preference type. Preference type. What are your preferences? I need an apartment with five rooms. I need to close to the beach. Whatever it is, and the maximum rent. This is my budget. I cannot pay rent more than or higher than this value. So, having this data, I can do my job. I can look for clients and match the client's preferences to the apartments we have available for rent that are not rented yet, and then convince them, and the process goes like this. If I need any questions, I can contact the owner and tell him this is the price I can get, and so on. So by having these data, I can manage do my job perfectly. The other department is the contracts department. The contract department needs to keep track of other types of data. What's the contract department? Contract department is the department after we agree with the client that this is the apartment. Yes, I like this apartment. Let me rent it. Okay, come and let us write a contract, the lease, the إيجار. So we need to keep track of these data. Yes, we need to keep track of the properties for rent for the clients, because those will be part of the lease. But what are the types of data? Let us look at the property for rent. Yes, we need the property number, street, city, postcode, and rent. But do we need to specify more about the apartment for writing the contract? Imagine you are writing a contract. All I need is which apartment, what's the address, and the amount of money to be paid every month. I don't need to know how many rooms, what is the type, whether it's apartment or villa or studio or whatever.
Maybe the date also.
The date, yes, but this is in the lease. In the lease, I write maybe the date. You may find, of course, this is sample of the information if the date is not here, but this will be in the lease. But about the property itself, about the apartment itself, there is no date, right? What I'm trying to say is the property for rent, compare the data required by the contracts department for the file. They call these files. So we have 3 files for the contracts. We have 3 files for the 3 files for the sales department, and 3 files for the contracts department. Compare the property for rent file, the data in the property for rent file, to the data for the property for rent for the contracts. You will find that most of the fields are there. We call these fields. We call the items here fields, and we call the whole thing a file. So property for rent, yes, all of these are here up till rent, but we don't have rooms, type, or even the owner number. We don't need them. So same for client. Compare the client here and there. You will find that there are some missing data. For example, we don't need preferences, because we needed the preferences for the sales department in order to find an apartment that close to his preferences, that matches his preferences. But now he already decided this is the one I want. So we no longer need the preferences, right? The budget. He doesn't need a budget. Maximum rent. Why? Because this is the rent. We have already agreed on the rent. I don't need to know what was your, was history, this is over. So what I want to say is, okay, there is a match. There are some common data required between the two departments, but they are not matched. It's not properly matched, right? It's not exactly the same. So what happens in the file system in the past, before inventing the concepts of database, this approach is called file system. So in the file system, as we said before, every department will hire a company, software house or something, to develop the program, or will hire their own programmer. Now these are two different programmers, they think differently, so but at least the analysis said this is the data we need and this is the data we need. So how the program will look like? The program will look like, we need to define the data as part of the program. That was what was happening before COBOL and whatever other languages. So the file definitions, these are files. So the definition of these files, what are the fields, what is the length of every field, what is the type of every field, is defined as part of the program. So the definition here in the sales program is different than the definition here in the contract program. Why is different? Because they are different. Because the programmers are different. Right? So although they both are using some common files, some common data, right? Before we leave this point, let us think of some mishaps, some mismatches. Okay. Assume this here about the client. The client, the designer here in the sales department, the programmer who wrote the program for the sales department, decided to make first name and last name separately in the sales department. Probably, maybe in the contracts department, he decides that to make it one single field, to write the whole full name, Muhammad Ahmed Abdul Samia. But here he wants to have it in two different fields, first name and last name. That's possible. So which means what? Means that the design, the definition of the client in this program is different than the definition of the client in that program. Got the point? Since the definition is, the file definition or the data definition is part of the program, so it is left to who? To the programmer who writes the program. And every programmer has his own vision, his own definition. So the definitions may be different. What else in the program? How to deal with file handling, how to deal with these files. So, for example, is it somebody makes some validation on the dates? We have dates, right? So somebody makes validation on the dates. Somebody else, some programmer else doesn't make validation. Things like that. So how to handle the data may be done differently. And then, of course, this is this part of the program is about how to enter the data, the reports required. So this is very specific to the requirements or the needs of each department. But what is of interest here is those two parts: the file definition and the file handling, the data definition and the data handling. There is a high possibility that they are not compatible. They are not 100% compatible. They are not exact match. What's the problem of that? I need to discuss now. What I want to discuss is the disadvantages of this design, this approach of the file system. So my first question is, what is the problem of having the definitions as built in as part of the program? The definition as part of the program,
you can't use it We can't use it in both systems. Every system has its own file definition. But if it was the same or match, we can use it only.
Exactly. The first thing is that we spend double the effort. Again, شغلنا مرتين to do this part, to identify the definitions, to identify the data requirements, and to identify the definitions. So double effort. Time means cost. مش كده؟ اتنين. Number two is, look at this. Every department owns his own data. So the data here is stored in his database, not database, I mean in his disk storage or whatever, which is in his own server, and this has his own server, and everyone has his own data. Now, the data is defined maybe differently. Not only that, there is a repetition, there is a duplication of the data, right? Look at the data about property for rent. All of these data here for the property are stored in the sales file. Also, they same are stored in. So we have the double storage. It is done twice, stored twice. What's the problem about this? Disk storage. More disk storage, more cost. مش كفاية. It's not only that. The most important problem is, it means that it is entered twice. Data entry, right? Time consuming. Not only that, the problem is more problems. If it's entered twice, let me assume that, for example, here the client telephone number is required by the two sections, two departments, right? Suppose that the client you used to talk to whom? To the salesman, right? Now he changed his telephone number. So he called the salesman and said, my phone number have been changed to this number, right? What will happen by the sales department? They are going to go and update. Update means change the telephone number to the new one, right? What happened in the telephone number stored in the contract department? Is it updated?
No.
It's not updated. Now, if for example, for a reason or another, we need the phone number. We need to call this client. Then the manager who wants to call the client called the sales department and asked what's the phone number of this person, this client. So they gave him the phone number. Now, for a reason or another, he called. He was in doubt, so he called the other department asking about the phone number of the same client. Will he get the same number? No. So which one to believe in? Which one is the correct one? We don't know. He doesn't know. The manager doesn't know. He got two phone numbers for the same person. Which one to call? Which one is the correct one? This is, of course, a simple example. One would say, let us call both and see. But I'm talking about numbers, about data. Maybe we are talking about money. We are talking about budgets of whatever. So there is a problem here. The inconsistency of data. This is a very important term you have to remember all over the course. Inconsistency of data. What does mean inconsistency? Consistency means the same data when requested by one way, you get one value. When requested by another way, it gets another value. So which value to believe? At the beginning of the lecture, we were talking about we need information in order to make decisions. So if the information is doubtfully, is not trusted, is not correct, then definitely the decisions will be incorrect, or at least I'm unable to decide because I am in doubt which one is correct. I lose trust in the data. Losing trust in the data, then forget the data. I don't need the data because I don't trust the data. It's useless to me. So inconsistency is one of the very dangerous, it's very dangerous for data. We need to avoid inconsistency. And we have a lot of work done by the database technique in order to avoid inconsistency. تناقض في القيم أو اختلاف في القيم. From where this inconsistency come from?
The difference program.
They come from the different the double storage, the duplication. Duplication means you are storing it many times. So the duplication or repeating of storing the data, the same data, many times. So there is no guarantee that there is a consistency between every occurrence, every occurrence of these data in the different places. So we need to avoid this. We need to change this design. We need to make those two come together to one storage, to one place, right? This will save us what? All of the disadvantages we have just mentioned. Single storage place, so no disk waste. It's going to be entered one time. And so no time. It's not only time, by the way. When you enter something twice, there is no guarantee that it is going to be entered all the time the same. There is human errors. Humans are error prone. This is a term we usually use in computer. Humans are error prone. They are عرضة لأنهم يخطئوا. Of course, their errors are not intentionally done. They are by mistake. Instead of pressing this button, I press this other button or key, right? So this is a mistake, and this is common mistake. When you are writing a student name, for example, I might misspell the name. So inconsistency is also expected even in by the same user, by the same data entry person. But the problem is bigger if they are two different persons, two different files, two different systems. So we need to combine, as I said, to make those two files into one single file. If this happens, this means what? We are talking about the data, right? The data, actual data. So they are combined together, so every piece of data, student name, or let's talk about this example, the telephone number, the client name, and so on, is defined one time and is stored one time. So not only the storage, but how about this file definitions?
They will be matched.
Will be the same, right? So if these are two different programmers, how can we make them match? Do they have to meet together and fight in order to get a single agreement? Of course not. What we do is let somebody else do the definition for them, right? So if some in here, in the middle here, before they start their work, there is somebody else who is going to define the data for them, okay? Now, this file definition is not required, right? It's not part of the responsibility of the programmer, because it's taken out of the programmer. This job, this part of the job, this task is taken out of the job of the programmer, right? It is done by somebody else. This somebody else is called database designer. Let us call it for now database designer. Okay? Now, the two programmers for the sales and contracts departments have the definition of the data ready. It is ready for them. All they need to do is to start writing the program without the need for this part of the program. They don't need to redo or redefine the data. Right? Agree? واضحة؟ if this is the case, and the data is not owned, by the way, look at these two pictures. The data is owned by what?
The program.
By the department. They have it on their own servers, right? Now the data we agreed now, let us change this approach and make the data common to all of them, right? Maybe we have 2 departments, 3 departments, 5 departments, whatever it is, but they all are using the same data with the same definition. This guarantees the consistency. And so now we avoid the problem of inconsistency. That's good. But if the data is not owned by the department, it's owned by whom? Should be owned. If it is owned by the department, like this picture, it means what? It means that he is responsible for everything that happens to the data. He has to take the backup. He guarantees that this is my own. This belongs to me, so I have to take care of it. Now, if it's owned by somebody else, who is going to take care of it? This one? This one? Nobody will take care of it. You are the responsible. You are the responsible. It comes here, no responsibility. No accountability. If something goes wrong, whom to blame? هنحاسب مين? We don't know, right? So there must be some owner to the data storage. Let me call it for now the data storage. Some owner to this. This owner must guarantee what? That you are properly using the data. You are not using the data in a wrong way. When you enter some field, some value, he must be sure that the value is correct. And you are following the rules as the data is designed. Got it? It's a safe access. And so he is responsible for managing the data, right? This means what about this program? So file handling is also moved to this manager. Give me this, store this, update this value, and so on. It's not done by the program. It is done by, it has to go through the manager, because he is the one who owns the data. So everything going to be done on the data has to be done through this manager, right? So it means that this program is not anymore in need for this part, data handling, because the handling is done by the manager, right? So look at the program. The program is becoming simple. Simple. It has only this part. Retrieve what kind of information you need. Retrieve this information. So ask the manager to get the information. Manipulate the information. Display it on the screen, display it on a printer, on a report. I mean, how to present the data. So the program is becoming so simple. If it is simple, then a young programmer, a beginner can write it, right? And it will not be as expensive. It will be, the cost will be, and the time to produce a program is, which means that we can generate, we can design, we can create more programs. More programs means more information. So now we will have a wealth of information in a very low cost, right? Once we design the database properly, the data definitions and the data storage properly, once we have this manager doing its job properly, then writing a program will be a simple task, right? Not only that, not only a simple task, but also all the problems have disappeared. The inconsistency problem, the duplication, the storage, the time, the error prone, and all of these errors or problems disappear, right? So we got a big advantage of having this approach. This is exactly what the concept of a database means. Let me move to another picture. This is, this is the new picture. the picture after redesigning the way of developing programs using the concept of database. So the database where the data are stored is common to all departments, not only 2 departments, 5, 6, many all departments, all the company. So we have a single database for the organization where no duplication, no inconsistency, everything is well designed, and we have a manager. This manager, the DBMS, is the manager of the database. So all programs have been reduced or simplified to just this part, the data entry and reports. Nothing related to the data definition or data manipulation, data handling, and all of these other data definition and data handling is moved to the DBMS, the manager. So who is going to define or design the manager? Isn't it a big effort, times consuming and so on? Of course not. Why? Because the DBMS is an acronym for Database Management System. These systems are available in the market. My organization doesn't need to build this manager. It is available in the market. All I do is just buy it. We last lecture show you some names of these. Let me move quickly. Yeah, here. No. Yes, here we have so many commercial DBMSs. Oracle, Formix, DB2, Access, Microsoft Access, you are properly familiar with Access, and so on. So we have many in the market, from a very simple one like Access, that's for one person, till a very big one like Oracle and Formix and DB2 for big databases and big organizations. So they are available. All I need is just to buy it, train my staff on how to use it, and that's it. So most of the problems we have discussed regarding the earlier approach of designing data applications is solved by having the concept of a database. So as we seen, this would be the picture. It's a very simple picture. Now look at the files. Let me call them files for now. They are now, we don't have 2 sets of files. Set for the sales and set for the contracts. We have only one set for all the organization, all programs in the organization, all departments, right? And look at the data. So we have only one file for the property of rent. We have only one file for the private owners, one for the client and one for the lease. Every department, every program needs any data of these, he just go and ask the DBMS to bring it for. But we don't have 2 properties for rent, 2 clients, and so on. So whatever you want, you will find it in the database. You just go and pick it. So the database management system is going to control, to manage how to deal with the data, starting from the definition of the data to the retrieval of the data, and some other activities like what, who is authorized to do what, maintenance of data, of course, yes, update and delete and insert, but also who is authorized to do what. Let us go back to the sales department and the contracts. We said that the sales department needs, for example, regarding the client, he wants to know the preferences and the maximum rent, right? But the contract doesn't need this. You remember the example? Yeah, to show you, let me show the slide again. Let us take the client as an example to explain this issue. So the contract doesn't care about the proper reference type and maximum rent. So he is not, the person here in the contract is not allowed, is not authorized to access these two fields, right? So what I mean is, in this picture, since the data is available for everybody, for all departments, but there is a controller here, the manager here, DBMS. So the manager says, oh, you are belonging to the contracts. So you are not authorized to see the preference type and the maximum rent. You don't need this. So why should access this? Why you should be allowed to change it or do whatever, right? You got the point? For example, the lease. The lease, all the data about the lease are not of concern to the sales department. They don't care about it, right? But the contracts cares about. So when the sales try to access the lease, he says, why? Why do you need the lease? You are not allowed. What I mean is, the part of the responsibility of the DBMS is to give or to grant access. Who is authorized to do what? Are you allowed to access this data? And if you access the data, are you allowed to do what with this? Just to view it? To update it? To change it? To do what? To delete it? So every person is authorized to do something with every piece of data, which gives more security to the data. Because now the data is common for everybody, so we need to secure it. So this is again part of the DBMS. I don't have to care about it as a programmer writing an application here. If I'm writing an application here, I don't care all of these securities. These are managed by the DBMS. So the DBMS is taking responsibility of many tasks that otherwise should have been done by the programmer. More effort, more time, more cost. You got the point? I'm not going to talk about maintenance of the programs, comparing the two approaches. Now we developed the program, but of course next year there might be a change. So we need to change the program for some reason. This is what we call it maintenance. So if you think about the maintenance, you will find more problems in the previous approach. Very big problem actually. But in this approach, most of these problems have been disappeared. I'm not going to discuss this. At least we are convinced that we have to have one common place to store the data for all the organization, and we need to have the one single definition for all the data. We need to have full control on the data to guarantee that manipulation of the data is done without any mistakes. So this is the responsibility of the DBMS. Now you got the idea, you got the difference, why we moved to the DBMS or the database approach. Now comes a question. If this is the case, where is the definition? How this program, any of these programs, can know the definition? In order to manipulate the data, I need to know how it was designed, how it was defined, in order to deal with it properly, right? How can I get this definition?
From the manager of the database.
I can go and ask the manager, the DBMS, what is the definition of the client? Is it full name or first name and last name? For example, if I'm talking about the name of the client. So in order to know this, of course, I go to the manager and ask him. So how the manager, my question now is, how the manager will answer this question? He must have maintained somewhere the definitions in order to answer this question, right? So how to store the definition? How to define the data? I understand how to or where to store or how to store the data itself. And we have seen an example last lecture. Let me show you again just to remember. I'm not following slides one by one as usual, but let me. Yes, here. This is a sample of a database where we store data about, for example, course, section, grades, prerequisites of the course. Let's take one of them as a sample. Course, we have course name, course number, credit hours, department, like we discussed yesterday or last lecture, right? So this is a table where I can store data about course. What do you need about course? I need course name. So we have course called Introduction to Computer Science. We have another course, data structure, discrete math, database, and so on, right? What else do you need to know about the course or to store about the course? Course number. So these are CS1310, CS3320, and so on. These are the course numbers. What do you need also? The credit hours, departments. So these are the fields, or we called them last lecture the attributes of the entities, right? So this is as simple as that. The database looks like this. It's so simple. We have data about the course, we have data about the section, we have data about grades, and so on. Every collection of data that are related to each other combined into one table. We call this table, right? Any question about these tables? Are they hard? Very simple. So this is how the relational database looks like. This is our database will look like this. Now I understand how to store the data. Back to the picture, to the last picture. Not this. This one. So we know now how to store the data. It is in the database in the form of tables, right? But where is the definition? Where is the definition which says that the course table, the table about the course, has course name, course number, credit hours, and so on? Where is this information?
In the system itself.
Where in the system? Where is
the database management system? Where
the database management system is a software that I buy.
Is that software?
No, it is a software that I buy. I buy Oracle, and Oracle is the same Oracle for KEU, for the bank, for the hospital, it is the same. It is a package like when you buy Word, Microsoft Word. It is Word for you, for you, for you, for you. It's the same word, right? But you write your own documents, he writes his own documents, and so on. But Word is Word. DBMS, Oracle, suppose that I buy Oracle, so Oracle is Oracle for any organization. It is the same. So it's not stored in this is a program. This is, the DBMS is a program. But where are the definitions? Where the definitions are saved, or where can I find them? In fact, they are stored somewhere. They are stored here, actually, together with the database. The definition about the data. So let us go back to our example in order to explain this. This is the data, right? We need to define these data. We have a definition for this data. So how about if I come and say, okay, the course, all I need, how to describe this? Let me ask you, Ibrahim, Ibrahim, what is the definition? How can you describe this table, this course table? How can you describe it? What kind of data or information you need to say about this table? I'm not talking about the data in the table. I'm talking about the table itself, the structure of the table. You would say that the name of the table is, and this course table has those fields, course name, course number, credit hours, department. And you might need also to say that the course name is a text of 30 characters, for example, the size, and so on. The credit hours are numbers, right? It is a number, and so on. So you need to, this is all the information I can tell about the structure of this table, right? I don't care about the data. You can write whatever data here. Got the point? So these definitions, this description that I have just said, can I store it in a file like this, in a table like this? Let me show you. So I can say this. Yes, I have a table called course. Right? We have a table called course. How many fields in that course? 4. What are the names of these 4 courses? 4 fields. So I come to this other table and look at starting here. We have, so we look at this field and search for the word course, and then these are the definitions. Of course, the definitions go more and more. So we have course name, it is a character, 10 characters. We have the course number, which is X here means letter, N means number. So it is 4 letters followed by 4 numbers. So this way I have been able to describe the structure of the table in the form of what? Table. In the form of a table, right? So the data are stored in a table. The description of the data is stored in a table. These tables looks like exactly the same like these tables. The same idea. Yeah? These tables contain what? Data. This is the database. If some other organization, hospital, bank, then the tables will be different. They don't have courses or sections. They have patients, they have doctors, but tables are different. So these are the data of my organization. These are the courses I teach, and so on, right? I mean, in fact, but the description of the data in a different other tables. So they call, because if this is the data and this is a description of the data, so they call it metadata. Metadata means description of a data. The word metadata means description, data about data. So this is a database also, right? But the content of the database is not the data. It is a description of the data. This is data about data, which is called metadata. So see this lecture. So the DBMS, this is the DBMS, has 2 storage. One for storing the data itself. This is the database, and this is where we insert students, new students, delete all the students, update student marks, and so on, right? And here is what? The description of these tables. This is the metadata. This other barrel here is the metadata. Now if I have the data stored this way and the metadata stored this way, let me ask you another question. If this is the data, right? This is the database. Now, can I add one more course? Of course, I can add a new record here. And then enter all of the fields for that record. Simple. Is it hard? Simple. What manages this? How this is managed? By who? By the DBMS. Yeah, the DBMS, I say, insert a new record, and these are the fields of the values of that record. So simple, right? Give him 4 values, he is going to store them in that table. It is his responsibility. It's a simple task. So I can add one more record. Can I delete? I no longer teach discrete math. Can I delete that record? Of course, simple. Send a command to the DBMS, say delete that record. So simple, right? Can I change the number of credit hours for the database course, the database course? Instead of 3, let me make it 4. Can I do that? Yes, I'll send to the DBMS saying change the value of the credit hours of the course database into 4. Make it 4. So simple, right? So dealing with the data in a database like this is so simple. Inserting new record, deleting an old record, updating one of these values in any field is so simple, right? Why? Because these are tables. Huh? How about this? Aren't they tables as well? No, wow, they are tables. They are tables, right? So if in tables I can insert, update, and delete very easily, then in these tables as well I can insert, update, and delete very easily, right? Right? Huh? So, which means, can I, for example, add to the course an extra field? Can I add to the student? Let me take the student as a simple example. Can I add to the student an extra field?
Yes.
How can I do that? I change this to 5, right? Yes. Instead of 4, it will become one more, means 5. And then I go and add one more record here. It belongs to, in the field, belongs to, it will be student. And then add this field, the properties of the field. So what is the column name? What is the type? So I insert a new record here. I go and update this value instead of 4, 5, and then I go and add one more record here to describe this extra field, right? So it's so easy to add one more field. Was this the case for the file system?
No.
Was it easy to add an extra field? Of course not. Why? Because the definition was part of the program. Remember, go back. The definition of the file was part of the program. It's not separate. It's not managed by a DBMS. It has, if you need to change the definition of the file, adding an extra field is a change in the definition of the file, right? Deleting a field, you no longer need that field, is a definition in the file. Updating the description of the field is another change in the file definition, right? So, but the file definition was part of the program, which means that I have to go and open the source code of the program and do the update, right? Maya, Ibrahim?
It's more complicated.
What, huh? How to open the file, how to open the source code. I must have the source code. Usually, when you buy, do you have the source code of Office?
No.
Of course, when you buy a program, you buy the executable only. You don't buy the source code. If you buy the source code, it's high expense. So this is one problem. I don't have the source code. Now I'm going to pay more to get the source code. Okay? هدفع أكتر عشان أشتري source code. Okay, I have the source code. And how can I do the change? I have to read the source code. I have to understand it. Who wrote this program? I don't know. It's not me. Somebody else. Where is the documentation? Probably don't have the documentation, or the documentation is out of date. There are those people who are working in the maintenance know a big list of problems they face when they are trying to do some simple change to an old program. This is called maintenance, program maintenance, changing a program. So it is very hard to do this in the old file. It's not only changing the definition, by the way, it's changing everything, any manipulation related to that change in the program. So you have to understand the whole program and see how to update or change, design your changes. But in this new approach, what is the problem? New approach. Huh? Oh, it's so simple. If I have a definition, just to add the definition. It's so simple. How? زي ما قلنا من شوية. ها؟ فين راحت؟ Yeah. You just handle it like exactly the same like you handle your data. It was just inserting or deleting or updating any of these fields here or records. واضحة الفكرة؟ So look at how great is this approach. Simplifies everything. So not only make consistency, guarantees consistency, manage the database, but also the changes to the data is the data structure or the data definition is so simple. Do we need changes? Do we really change the database? Of course, yes. I cannot live with a program exactly as it was 5 years. Of course, during the 5 years, there are many changes around us that cause a real need for changing the data or the data structure, right? So yes, expect that you will go and do some changes every once in a while. So having this approach of database makes this so easy and so simple. Questions? واضحة؟ نقول بالعربي؟ No need. Okay. Now this picture also shows. Okay, here is the database management system, DBMS, and of course it maintains two types of storage, as we said. The database itself, this is what is of interest to you as a user, but this it also maintains the metadata, the definition of the data of the database in another storage, and this is of concern of the program designer. So this is of concern or interest to the users. This is for the designers. Okay. Not only that, there is another great advantage. Usually in the old approach, in order to write or in order to answer a piece of information, one simple information is required. Of course, I cannot guess all types of information I need. So what usually is done is what are the common information you need in your organization. So we design our programs based on this. We design some commonly needed queries and write programs for that. Programs. Here are the programs. Okay? But by time, it happens that we need this information in order to make a design. Some new occurs. So what happens? The manager who is going to make a decision asks for this piece of information. So he goes to the IT department and says, bring me this piece of information. They said, our system don't produce this information. So wait for a while until we write our programs, maybe 2 days, 3 days, whatever, write programs in order to be able to retrieve or to bring out this information, right? So now the information will come few days late. We said it's good, it's important that the information is accurate, and this has been solved by the consistency, okay? And another important property for the information is to come on time. If it came late, then it's useless. So now if I have to wait 2, 3 days, 4 days, 5 days, I don't know, then it is late. So useless, because we need to write a new program. Although it's a simple program, but it takes time. Now, the DBMS gives me another advantage, that I can contact the DBMS مباشرة, directly. I can contact the DBMS directly and ask him, here is my query, give me the answer. So directly, as a user, here the user interacts with a program, so we have to write a program. But in the case of a DBMS, the DBMS gives me a language, we call it query language, that allows me to communicate directly with the DBMS and ask my queries. So a manager, by very simple education, we can educate him. Here is how to write your queries. He can answer his or bring his information by himself. If he doesn't have the skill, he asks the IT department and they can give it in 5 minutes. They can, okay, give me 5 minutes and I'll call you back and tell you what is your answer. What's the answer to your question, okay? So this is another advantage. Quick response to queries, okay? In order to do this, the DBMS provides us with 2 types of languages. 2 types of languages. Sorry, I have to find, yes, it is here. Data definition language, in order to allow us to define the structure of the database. We talked about this. So how to define it? So I'm going to communicate with the DBMS by writing a data definition, by using a data definition language to tell them, yes, I need a table called students. I need in this table the following fields: student number, student name, and so on. And the size and type of every one of these fields is this. So I tell him my definition. Who is doing this? Not the programmer, but the database designer. Okay? Database administrator, actually. But anyway, someone responsible for designing the database will tell or will use the data definition language. So there is a language. Another language is the data manipulation language. The language that we were talking about, the queries. I go and ask the database, give me the number of students who got an A in a certain course. So there is a language to tell them how to ask the DBMS such a question. So there is another language called data manipulation. In fact, there is another language, not the query. Data manipulation is of 2 parts. Actually, the query, ask questions, informations, and also the manipulation, storage, insert this record, delete that record, update this value, and so on. So we have 3 languages made available by any DBMS. How to define the data structure, this is called the data definition. This is called data definition language. We also have data manipulation language, or data maintenance. We call it maintenance: update, insert, and delete. And we have the query. 3 languages are made available by any DBMS in order for us to be able to communicate with the DBMS in a common way. Not everybody communicates his own way. Something like you write a program, you use Java, use C, and so on. Okay? Next time we'll start by talking about the what are the services that a DBMS can offer to us. So, any questions before we leave? Okay. Thank you. ناخذ غياب